Did you know that in late 2025 our solar system is about to host the cosmic traffic jam of the century? I'm not talking about one or two comets. I'm talking about a swarm of 7 major objects all diving towards the sun in a tight 6-month window. This is the kind of event astronomers haven't seen since modern telescopes began watching the skies. So, why is this happening now? And what does it mean for us? Could we see solar storms spike? Will one of these visitors flare bright enough to be seen with the naked eye? Let's break down the rarest comet calendar of our lifetime. 7 major comets crowding the inner solar system in a single season is almost unheard of. Most years, we're lucky to spot 1 or 2 bright ones. But a year with 7, all arriving in just a few months? That's an event that stands out in a century of observation logs. And this isn't just a slow trickle. It's a concentrated rush. Some are coming from the farthest reaches of our solar system. Others are periodic visitors making a return trip. But one of them, the interstellar heavyweight 3I Atlas, isn't even from around here. An interstellar comet alone is major news. But paired with 6 other sizable comets, the odds become almost impossibly small. Statistically, since the year 2000, we've averaged just 1 comet per year that's bright enough to see with the naked eye. Many years pass with nothing but faint, distant fuzzballs. Even so-called comet showers rarely feature this many players. Public logs show that no season in the modern digital era has hosted more than 4 major comets with orbits this close to the sun. The 2025 influx is so unusual that some astronomers are calling it a statistical outlier, a once-in-a-generation phenomena. That's why this isn't just a list of objects. It's a true swarm that challenges everything we thought we knew about the solar system's usual rhythm. Astronomers are now treating this as a single, multi-act event, tracking the collective choreography of these cosmic dancers. How will their orbits and solar encounters interact? It's this rare convergence that's fueling both scientific excitement and public anticipation. Let's take a look at the schedule. The season kicks off on July 31, 2025, with C2022N2 Pan-STARRS. It's a quiet start, as this one stays far out beyond Mars, but it marks the opening act. Then things heat up. C2025 R2 SWAN arrives on September 12th. The real highlight comes on October 21st, when SWAN sweeps past Earth at just 37 million kilometers. This close approach makes it a prime candidate for viewing, especially in the pre-dawn sky for those of us in the northern hemisphere. Next is 414P Stereo, swinging around the sun on September 27th. Its orbit dips below the ecliptic plane, the flat disk where the planets orbit, making it a tricky target for us on the ground, but perfect for spacecraft to get a unique view. C2025K1 Atlas arrives on October 8th, diving even closer to the sun than Mercury. This tight solar pass means Atlas will change rapidly, making it a key subject for watching how comets develop their magnificent tails. And then there's the main event, 3I Atlas, the interstellar visitor. It passes behind the sun on October 21st and reaches its closest point to the sun on October 29th. For a few days, both 3I Atlas and SWAN will be in critical positions for scientists studying how the sun interacts with these icy bodies. See 2025 A6 Lemmon peaks on November 8th. This one will be visible in the evening sky after sunset, offering one of the most accessible viewing windows for everyone. Forecasts suggest it could reach magnitude 4, potentially bright enough to be seen with the naked eye from dark sky locations. Finally, 240P Neat completes the sequence on December 19th. It's fainter and farther out, but its presence underscores just how crowded the inner solar system will be by the end of the year. Now let's talk about those iconic comet tails. They're more than just pretty cosmic streamers. They're a direct link to the invisible forces of the solar system. When a comet gets close to the sun, it heats up, releasing gas and dust. This creates 2 tails, a broad, pale dust tail and a narrow electric blue ion tail. The ion tail is made of charged particles swept away by the solar wind, the constant stream of plasma flowing from the sun. But this tail isn't permanent. It can be snapped off in an instant in what's called a tail-disconnection event. This happens when the comet flies, through a sudden change in the sun's magnetic field, like a solar storm or coronal mass ejection, also known as a CME. When the magnetic field flips, the comet's plasma environment can't keep up. The old tail is severed and drifts away, while a new one grows, perfectly aligned with the new magnetic field. We saw a textbook example in 2007 when a NASA spacecraft watched a CME slam into Comet Encke, cleanly severing its tail. With so many comets diving near the Sun in late 2025, during a period of maximum solar activity, the chances of seeing a live disconnection event are higher than ever. This brings us to a fascinating debate among solar physicists. Some researchers, like the NASA modeling team, believe this swarm of comets could actually nudge the Sun toward more frequent or intense outbursts. Their simulations show that when a dense comet crosses the Sun's magnetic field lines, it can trigger instabilities, especially during a CME. The excess plasma from the comets might even seed new disruptions in the solar wind. However, not everyone is convinced. Teams from the Solar Orbiter and Parker Solar Probe missions point to their own data, arguing that most tail disruptions are much more subtle. They've seen plenty of kinks and bends in comet tails that never turn into full-scale disconnections. In their view, the Sun's own magnetic cycles are the real drivers, and comets are more like passive tracers than active agents. They caution against overestimating any risk to our satellites or power grids. But with CME rates expected to hit 2 to 5 per week during the late 2025 solar maximum, both camps agree on one thing. This is a once-in-a-lifetime opportunity to test their theories in real time. Space weather agencies are ramping up monitoring, and citizen scientists are preparing for a global campaign. If a major tail disconnection happens while a comet is in view, observers from backyard telescopes to space missions will be ready to capture it. So late 2025 is shaping up to be an extraordinary time for skywatchers and scientists alike. It's a chance to witness a rare cosmic convergence and learn more about the dynamic, ever-changing nature of our solar system. Mark your calendars, because this is one celestial show you won't want to miss. Have you ever looked up at the night sky and wondered what's passing through? Well, get ready, because 2025 is shaping up to be an absolutely incredible year for skywatchers. We're not just talking about one comet. We're talking about a celestial swarm, a cosmic parade featuring at least 3 fascinating visitors. We've got Comet SWAN, Comet Lemmon, and the star of our show, a truly bizarre object from beyond our solar system called 3I Atlas. This isn't just another light in the sky. It's a scientific mystery that's unfolding right before our eyes, and it's challenging everything we thought we knew. So, what makes this 3I Atlas so special? When astronomers first charted its path, something immediately seemed off. The numbers just didn't add up. Its orbit wasn't the gentle, looping ellipse of our local comets. Instead, it was a hyperbola, an open-ended trajectory with an eccentricity way over 1. In simple terms, this thing is not from around here. It's a one-time visitor, a tourist from another star system, just passing through, and it will never, ever return. This fact alone puts it in an incredibly exclusive club. Before Atlas, we had only confirmed 2 other interstellar objects. The strange, cigar-shaped Oumuamua in 2017 and Comet Borisov in 2019, but Atlas is a whole different beast. The scale of this object is just mind-boggling. Early peaks from the Hubble and James Webb Space Telescopes suggest its solid core, its nucleus, is somewhere between 320 meters and 5.6 kilometers across. That's a huge range, and we'll get back to why that is. But the real showstopper is its coma, the fuzzy halo of gas and dust it's shedding as it gets closer to our sun. This coma has already ballooned to about 700,000 kilometers wide. Let that sink in. That is nearly the size of the planet Jupiter, and it's getting bigger every single week. It's like watching a cosmic snowball unravel into a giant, ghostly cloud. Unlike the comets we're used to, which have spent billions of years locked in the cold outer fringes of our own solar system, Atlas comes from much, much farther away. It was likely thrown out of its home star system, sent on an interstellar journey carrying materials forged in a completely different cosmic neighborhood. And we can see this in its chemical makeup. When scientists analyze the light coming from its coma, they see something unusual. It's dominated by carbon dioxide and other volatile gases. Water vapor, which is usually a key ingredient in our comets, is strangely scarce. Even cyanide is only found in faint traces. These are chemical fingerprints we rarely see in such large amounts on local comets. It's like getting a sample of air from another world. The way it moves is also a dead giveaway. Atlas entered our solar system at a really steep angle, barely skimming our planetary plane by about 5 degrees, and its speed? It's moving so fast that there is absolutely no doubt about its foreign origin. It's not gravitationally bound to our sun. For scientists, this is a golden opportunity. Every single observation is a chance to compare the fundamental building blocks of a distant planetary system with our own. Are we made of the same stuff as the rest of the galaxy? Atlas holds clues to that answer. But there's more at stake than just chemistry. As Atlas whips around the sun, it's leaving a trail of dust and debris behind. And guess what? Earth might cross through that trail in 2026. This gives our planetary defense teams a rare chance to study interstellar material up close and personal, to see what it's made of and how it behaves. The story of 3I Atlas is far from over, but it's already rewriting the book on the boundaries of our solar system. So when can you see these cosmic travelers for yourself? Mark your calendars for late October through early November 2025. This is when the sky opens a rare window for comet watchers, and you won't need a professional telescope. The show kicks off before dawn on October 21st, when Comet C 2025 R2 SWAN makes its closest approach to Earth, flying by at a comfortable distance of about 0.25 astronomical units. Through a simple pair of binoculars, SWAN's tail is expected to stretch out an astonishing 2.5 degrees across the sky. That's 5 times the apparent width of the full moon. Its head will be glowing at around magnitude 6 or 7. That's faint, but definitely within reach for anyone willing to get up early and scan the southeastern sky. For most of us in the northern latitudes, SWAN will climb to nearly 40 degrees above the horizon just before sunrise, making it a perfect pre-dawn target. While all this is happening, our interstellar friend 3I Atlas will be playing a game of hide-and-seek. It will slip behind the sun, an event astronomers call a superior conjunction. While we won't be able to see it from the ground, the action moves online. Solar observatories like Soho's Lascaux coronagraph will keep a constant watch. These amazing instruments block out the sun's blinding glare, allowing us to see the faint corona and anything passing through it. You'll be able to see real-time feeds of both 3I Atlas and, at times, Comet SWAN as they appear as faint moving dots against the sun's wispy outer atmosphere. These feeds are public, so anyone can join the hunt for sudden outbursts, changes in brightness, or even a dramatic tail-disconnection event, which can happen if a comet gets hit by a solar storm. Then, by early November, another player enters the stage. Comet C 2025 A6 Lemmon is set to steal the spotlight in the evening sky. Forecasts predict it could reach a brightness of magnitude 4, maybe even 3.5. That's bright enough to be spotted with the naked eye from a dark location, especially for those of us in the northern hemisphere. Lemmon will be sitting low in the southwest right after sunset. You'll be able to watch its coma and tail get brighter each night as it races toward its closest approach to the sun on November 8th. For many people, this will be the easiest and most accessible comet to see in years. So whether you're using binoculars, a backyard telescope, or just your own eyes, this is a season to get outside and witness the solar system in motion. The key dates to remember are October 21st for Swan's Pass and the week of November 6th through the 12th for Lemmon's prime time. Now, I have to be honest with you. Forecasting how bright a comet will be is a lesson in humility. It's notoriously tricky. No matter how much data we have, brightness predictions can be off by a lot. A comet we expect to be a blazing spectacle can end up being a faint fuzzball, while a quiet, overlooked comet can suddenly erupt and outshine everything. Why? It comes down to factors that our models just can't fully account for. Things like the size of the dust grains it's shedding, the specific mix of ices frozen on its surface, and how sunlight penetrates a crust that might be meters thick. A tiny shift in how the sun heats it, or a hidden fracture deep inside its nucleus, can change the entire story overnight. For an interstellar object like 3I Atlas, the uncertainties are even bigger. As I mentioned, its nucleus could be as small as a city block or as large as a mountain. Our best telescopes can only give us a range. The true size is still a mystery. We know its massive coma is full of carbon dioxide, but the complete inventory of all the other gases and dust types is still unknown. Without a strong detection of water or other familiar chemicals, every new piece of data forces scientists to rethink their theories. The only thing we know for sure is that the forecasts will keep changing right up until the moment it passes the sun and even after. But this uncertainty is what makes it so exciting. Looking ahead, new technology is coming that will help us catch more of these cosmic wildcards. The Vera Rubin Observatory's upcoming Legacy Survey of Space and Time, or LSST, will routinely scan the entire sky, spawning faint, fast-moving objects that we might miss today. But even in the era of super surveys, the science will be driven just as much by the things we do and see coming as by the things we predict. For now, the best advice I can give you is to watch the sky with an open mind and always expect the unexpected. 3I Atlas, with its enormous carbon dioxide coma and mysterious interstellar origins, is a testament to that. This 2025 comet swarm is more than just a light show. It's a live experiment that will test our understanding of comets, our sun, and our place in the cosmos. It's a new chapter in the story of our solar system, and you have a front row seat. Thanks for joining me on this cosmic journey today. Don't forget to look up this coming year. If you enjoyed this and want to stay updated on all things space and science, please hit that like button and be sure to subscribe and turn on notifications so you don't miss our next adventure. See you next time.